Okay, here we are. This is video 2 for unit 2 about population, and today we're talking about population in space. We saw in the first video about density and distribution. So we should know that even though there are 7.6 billion plus people on the Earth, that population is not evenly distributed across the Earth. So we have some countries that have a lot more people. We have some countries that are very populated. But half the countries on the Earth have populations of less than 5 million people. Just to give you an idea, Palm Beach County is already 1.5 million. So when you map density or distribution, we always need to make sure that you're identifying the scale of analysis. Are we looking at a map that is showing us county by county data? Is it showing us the 50 states of the United States? Is it showing us all of the countries of Latin America? Is it showing us the entire Asian continent? So we have to be sure about scale of analysis because they will always try to make you analyze the data, quantitative data, qualitative data, but they'll always be changing scale. So make sure you're ready for that. We talked about density in the last slideshow. Remember, density is just mass divided by volume, but we have different kinds of density. So today we're going to be talking about arithmetic density, or basically arithmetic. This is literally just dividing the mass divided by the volume. Take the number of people, divide by the total land area, you'll get a number. That really doesn't help us a whole lot, though, because not all countries are created equally when it comes to farmable land and land that's productive for agriculture and things like that. So in just a second, we'll talk about a different kind of density. So what we need to realize is that population and space are an inherently environmental consequence. So when you think about your 5 themes of geography, when you think about location, place, human environment interaction, regions, and movement, you know that population is a big part of all of these 5 themes. And don't forget, when we think ESPN, economic, social, cultural, political, and environmental, that's also important as well. So arithmetic density, persons per square kilometer. Basically, what you see here is that India is very densely populated, but so are Japan, South Korea, the Philippines, Vietnam, the Netherlands, and Belgium, Haiti, El Salvador, the most densely populated country in the Western Hemisphere, Rwanda, Burundi. What you'll notice is that most of these countries are pretty small, and they have a lot of people, therefore more people per square mile. But in India's case, it's because they're super populated. Remember, India is in excess of 1.3 billion. So even though it's a big country physically, it also has a lot of people. Next door, Bangladesh is about the size of Colorado, but that population is in excess of 200 million people. When you look at China, kids will say, well, I thought China had a lot of people. They do. They still have about 1.4 billion. But remember that China is physically much bigger than India, so that density is spread out over a larger space. So remember density and distribution. Indonesia has less people than the US, just barely, but we have a lot less people per square mile because the United States is much bigger. Don't forget, Canada factors into that as well. And remember, when we're doing a choropleth map and we're doing it at the country scale, whatever the United States shows, Alaska and Hawaii are part of the United States, so they'll show up in the same color scheme. It doesn't mean that there's a lot of people in Alaska. There's actually not. Palm Beach County has more people than Alaska does. So this is cool to look at the density across on a choropleth map. Remember, of course, the 5 twos. And we've talked about this several times in class throughout the year. Generally, people don't live where it's too hot, too cold, too wet, too dry, or too rocky. We're like Goldilocks. We like things to be temperate, just right. So that's why you see a lot of population around the 40-degree latitude mark. Not a lot of people north or south of 60 degrees latitude, because those are your polar zones. Not a lot of people along the equator. Not even all that many people in the tropics, because generally too hot, too wet. Your biggest populations, and if you go back and look at this, you'll see that at about 40 degrees latitude and longitude, look at the European countries, right? Look where China is, the United States, Brazil, all of these countries extend pretty far south of that equator and into that tropical area, and then getting more towards the temperate climates. When we talk about density and distribution, we talk about population and space. This is a fun thing that we always love to talk about. Can all humans fit into Rhode Island? When we think about carrying capacity, it's not how many people can fit in the space. It's can the place economically and environmentally support and sustainably support that population. So if we do the statistics, and I looked this up just the other day, 7.596,357,813. That's 7,596,357,813 people. But of course, in the time it took me to say that number, we know that people have been born and people have died. Population numbers are constantly changing. They're unreliable. But let's assume that number. Rhode Island is 1,212 square miles. Population density is mass divided by volume. So if you take the number of people, divide by the square miles, and by the way, there's 27,878,400 square feet in every single square mile, you'll get 33 million, is that million, billion? That's 33,788,620,800 total square feet in Rhode Island. Divide the number of billions by the number of billions of total square feet. You can see the math. It's about 4.44 square feet per person. We all fit, but we wouldn't want to live there. First of all, what would that smell like? And by the way, if you're interested in what a square foot looks like, walk in my classroom and look at the floor. Every one of those tiles is 1 square foot. So physiologic density, much better than arithmetic density for trying to figure out if a country's overcrowded or not, because here we're only looking at what they call arable land. I always like to tell kids arable land is AKA farmable land. So this is agriculturally productive land. When I showed you the map in class about the 10 Asian countries that grew a lot of rice, you'll notice that a lot of those countries have a lot of arable land. But China and India, for example, they struggle. Some of their territory is not exactly arable because it's too hot, too cold, too wet, too dry, or too rocky. So they have to farm everywhere they possibly can. What this means is that their arithmetic density number might be not so big, but their physiologic density number is going to be enormous. The best case study for this is Egypt. Egypt is about the size of Texas. It has 70 million people, give or take. There's about 182 people per square mile, but 97% of Egypt is sand. The only farmable land is up and down the Nile and in what they call the Nile River Delta. So if you look at just the farmable land, their physiologic density comes out to over 9,000 people per square mile. So this is what we mean when we say carrying capacity. How many people can the country support? Nobody worries about Japan being overcrowded, even though it's only the size of California and it has 4 times the population of California. We don't think of Japan being overcrowded. Why? Because they're rich. They make tons of expensive products that they sell all over the world, and they have no trouble providing enough food. On the other hand, you look at a country like El Salvador. It's a tiny little country, very heavily populated, and it's really poor. So we worry about them being overcrowded. Will they be able to support their population? Even a country like Nigeria that I mentioned in the last video. It's only the size of Texas, but it's already 200 million people, and it's forecast to double in the next 30 to 40 years. That's going to be a serious problem of overcrowdedness. There's one more kind of density that we should mention, and this is what we call agricultural density. Quite simply, this is the number of farmers per unit of land. So arithmetic density, just mass divided by volume. Physiologic density, it's the number of people per square mile or per square kilometer of agriculturally productive arable land. If it's agricultural density, it's the number of farmers per unit of land. This is a great picture of Egypt. And when we took kids on the spring break trip to Egypt several years back, we did a Nile cruise. And this was one of the things that really hit me hard, was that as you went down the Nile, there was this ribbon of fertility, the darkest, blackest, most productive soil I've ever seen in my life. And all of this green, because all of this agriculture that was happening. And literally maybe 600, 800 yards beyond that green ribbon of fertility was literally just nothing but desert for as far as the eye could see. It's really incredible how Egypt is able to support its population. And remember, this is for several thousand years they've been supporting this population based on the gift of the Nile. So here's a great map that shows you physiologic density. And if you remember, we went back a couple of slides and there was a slide about arithmetic density. And India, for example, was really high on the arithmetic side. But on the physiologic side, you see it's not as much of a problem for them because they're able to produce a lot of food and they do have a lot of land that is farmable. Meanwhile, Egypt, remember we said, was very high. Venezuela and Colombia, both high on physiologic density. That's because a lot of those countries are getting into the jungle of the Amazon. A lot of that land is very forested. It's a rainforest type of a climate. The soil quality is not so good. So again, it's very difficult to grow that kind of food. Even someplace like the UK or Iceland, really cool, not great places to grow a lot of crops. Japan, the same way. Indonesia, the same way. The Philippines, super rugged and mountainous. This is why they have to cut terraces into the side of the mountain to be able to grow their rice. Places in the Middle East where it's extremely dry, arid climates, desert-like climates. These are places. Switzerland, again, really mountainous. So we have these issues. Now, Canada and the US, they show up as being, even Argentina, Russia, Australia, they don't show up as having that many people per square mile of arable land, because in the case of Australia and Canada and some of these, Mongolia, remember, Mongolia only has 3 million people in the whole country. Australia, a little over 30. Canada, a little over 30. Russia's half of our population. Argentina, barely 45 million. So even though those countries don't have the greatest arable land, they also don't have big populations. Of course, the United States does have a big population, but of course, we're also blessed with tremendously fertile and abundant crop and agricultural lands. So where are these major concentrations of people in the world? Essentially, you need to know the big four. Eurasia has 3 of them. East Asia, which is basically China, has that first big population. The second one is South Asia, and again, basically India and their neighbors. The third one is in Western Europe. And then the fourth one, and it is a distant fourth, is North America. Basically, what I want to show you on this next one is some of these patterns of the big population concentrations. The Northern Hemisphere, remember, has way more people than the Southern Hemisphere. Remember, the Southern Hemisphere is Antarctica and a lot of water, and places in South America, Africa, and Australia that are pretty much uninhabitable because of the 5-2s. So how will the College Board group your regions? These 2 maps here can show you all of the big regional names that you kind of need to commit to memory, and make sure that when you compartmentalize and chunk the Earth into regions, you can see these areas of the world on your mental map. Again, this is a good example of changing scale. Here are the bigger regions, and then we break them down into the subregions. For example, Latin America. You've got the Hispanic part of Latin America. Remember, Brazil is Latin, but not Hispanic. The Caribbean as a regional name. West Africa, South Asia, Southeast Asia. All of these are great examples of how the College Board will take the big regions of the world and chunk them into smaller regions. That does it for this video. We'll try to keep them all between 12 and 15 minutes so you can chunk it up and not have to spend too much time watching any one video.